Hello guys, I'm Aluko Shayo Enoch. Welcome to my math tutorial class on linear programming. In this tutorial, I'll be working on the IGCSE exam style question. And point to know on linear programming. A linear programming is a mathematical technique concerned with allocation of scarce resources, and it is a procedure to optimize the value of some objectives based on given constraints. For example, we maximize profit or we can minimize costs. Guys, in most linear programming problems, there are two major strategies or stages, whatever. Okay, stages better. The first stage is to interpret the information given as a series of simultaneous inequalities, and we display them graphically. And the second stage, we are to investigate some characteristics of the point in your shaded solution set. So if you look at this question now, the questions reads, a hotel manageress is to order some sunbeds. Okay, so a hotel management is to order some sunbeds. Okay, so probably this yeah, this is to order some sunbed for business purpose, so you understand what is going on now. So there are two types available. We have the wooden and the plastic bed. So she must order at least 30 wooden sunbed and at least 60 plastic sunbed. She can order at most 200 sunbed. Each wooden sunbed costs 400 pounds. Guys, is this euro or pounds? Okay, whatever, I think it's euro, and occupies an area of 2 square meters. So each plastic sunbed cost 12 pounds and occupy an area of 3 square meters. So she has 3,600 pounds to spend, and the sunbed must, and so on and so forth, guys. So the task here is we have to write the six appropriate inequalities suitable to model the managerial situation. So we want to use the inequality to model this information here, and that is the first stage. We have to interpret the information as a series of simultaneous inequality, and that's the first thing. So let's interpret this information as a series of simultaneous inequality. So let's get started with I just let me take a form of square box, and let me have all my question in this rectangular box. Okay, so the first task, guys, so this is the first task here. So she must order at least 30 wooden sunbed. So before I can start this question, let me just make some representation. Okay, let our wooden sunbed be x, and our plastic sunbed, let's represent that one with variable y. So we have two variables we are working with now. We have x variable that represents the wooden sunbed, and we have the y variable that represents the plastic sunbed. So anywhere I see anywhere this word, I cite this word wooden, we use x. Anywhere I cite this word plastic, then I will use y. So she must order at least 30. So at least means that 30 and above. At least the minimum is 30. And what I want there is wooden, and wooden is x. So x, at least the inequality sign at least we take is greater or equals to. So that's the first inequality sign. So x greater or equals to 30. So that's okay. And at least 30 plastic sunbed. So plastic is y, and that is also at least 30. So that, sorry, at least 60. So that is 60, 70, 80, 90. So it's greater than 60 or equals to. So y greater or equals to 60. So I'm through with that first part of the question. So let's represent this second information. Okay, she can order at most 200 sunbed. So all together we have wooden and plastic. So this is sunbed all together. So this is related to both x and y, so that is the sum. So that means we can have x plus y. We will have sunbed all together. So x plus y at most. So most means that the maximum is 200. So and you can go below. So since that will be below, that will be less or equals to. So less or equals to, because the maximum is 200. So that's a good one. So let's go for the next information and represent it also. So each wooden sunbed cost, okay, so now this has to do with money, 40 pounds, and occupy area. So this is area. So we have two different information here. So we have area, and we also have costs. Okay, so let's just keep this and see what we are going to do with that. But this has to do with the wooden sunbed. Okay, so this has to do with x. So something will be something like 40x. This will be something like 2x. Okay, each plastic sunbed cost 12 okay pounds, and occupy an area of um 30 square meter. Okay, so this has to do with y, something like 30y and 12y. Okay, so she has, okay, now so we can, this is everything about, so she has 3,600 pounds to spend. So and let's work with this now. So this is the total money available for her to spend. So let's work with the money now. So I'll work with these two now, with these guys now. So 12 and 40 here. So then we'll combine that with three 600. So now the 40 is for that is for wooden, and wooden is x, so that means 40x. 40x. Okay, and the 12 is this 12 is for plastic, and plastic is y, so that is 12y. So don't forget, this is 40x plus 12y. Okay, so that's the amount. So altogether she has this, so this is all she has on her, and if this is all she has on her, so she can't spend more than that, so that will be less or equals to, guys, I can reduce this 3600. I'm going to reduce it later. Maybe let me just do that now, guys, or let's just go ahead and work with it. I can reduce it now, I can also reduce it later. Okay, so and that's that. Okay, let's just let's reduce that. Let's just divide through by if you divide through by 4, I think that would be good. Let's divide through by 4. So let me put this one in square bracket, because this information I want to rewrite it, because this is a big value. I can't represent this one on inequality graph, so it's better for me to reduce the value. So let's reduce it. So divide through by 4. So if I divide by through by 4, then I will have 10 here. 10x, so plus 3y, plus 3y. I'm dividing through by 4, so that will be less or equals to divide through by 4, guys. Am I correct? Yeah, so let's just see 3600 divided by 4. I need to use my calculator. 3600 and divided by 4. Okay, so that's 900. That's not a bad deal, so we can work with that. There is nothing common again, so I can't reduce this further, so that's the highest common factor, so that's a good one. Okay, I think at this stage okay, don't worry, let's just continue. So we have 1 2 3 4. Okay, we need 6 altogether, so 2 more. Okay, also, and she and the sunbed must occupy an area of at least, so this is everything about the area, and this is the minimum. So this at least means that it can go beyond this area. Do you understand? She can walk more than this, beyond this area. So this will attract greater or equals to, and so the 2 is for sunbed, and sunbed is sorry, wooden. This 2 here, 2 square meter, is for wooden sunbed, so that is x, so that will be 2x, and this area here is for plastic, so that will be plus 3y. Okay, guys, hope you are flowing, guys. There's something I miss out here. This should be less or equals to, right? Less or equals to. Okay, so let's continue this one. So at least, so this is the minimum, so I can, so that will be greater or equals to, because at least is 300, so it can go beyond that, so that will be greater or equals to 300. So I have 5 inequalities all together now. It's remaining 1 more, I believe, if I'm right. It's remaining 1 more, right? Okay, so then she must order, guys. Guys, you need to listen to this explanation. I'm going to explain this one here, this one, then I'm going to express my inequality. So let me just put this one here, guys. Okay, so now she ordered at least 50% more. So 50, this working in percentage. So if you are working in percentage, I would rather work in 100%. So 50% more means something like 150. Okay, so 50% more sunbed, and sunbed is what? Sunbed okay, sunbed altogether. Sorry about that. Okay, plastic. That's a bar. So plastic. So plastic is y. Don't forget, plastic is y. Okay, so 50%. Okay, and then wooden. So in that case, I'm going to use 100% for wooden. Okay, so now let's wouldn't be 100%. So I'll write, so let x, so x equals to 100%. So because that is wooden, so it's plastic that is 150 more. So 50 more. So if that is 100%, so plastic will be 150%. That is the implication. Plastic will be 150%, and plastic is y. Okay, guys, since I'm working in percentage, I can just cancel out this percentage. So you understand how I come about my 100 and 150 now. So now at this stage now I can go ahead and I'm going to I can go ahead and cross multiply. So if I cross multiply now, this is 150x equals to 100y. I can reduce this one to, let's just reduce from let's do, and let's read let's just continue. So 150x, okay, equals to 100y. So at this stage I can go ahead and reduce now. So I can reduce this. Let me first take away this 0 0. So I reduce by 10. Then 5 I can reduce by 5 now. 5 in 15, 3. So that's 3x. So the relationship is such that I have 3x. I'm relating. It's not equal sign, guys. It's just to use them. So I'm relating. Let me just use relate. I don't know if it's the equality sign to use yet. So I'm relating 3x. So let me just put asterisk here. I'm relating 3x and call this one 2 by 5 and 2y. Okay, so let me go back to the question now. So this one says that she must order at least 150 more plaques than the sunbed. So I can go ahead and write y first, because if you always express y in terms of x, because the independent variable is x and the dependent variable is y. So in that case I can write 2y now. So 2y. So I can now use the inequality sign now. So more means greater than. So 2y is greater than something like that. So equals to. So then I can now have my 3x. So that's the inequality. That's the final inequality sign. Guys, hope you understand that concept. Okay, you need to understand that. So the final one is 2y. Okay, greater or equals to 3x. So and that's all. So I'm through with this question, guys. So that's a solution to the first question. So the only thing is that I'm going to I will need this information to plot my graph. And since I need this information, the best thing for me is just to, let me just copy it. Okay, I need to take print screen now. So my light shot is not active. Let me quickly bring out my light shot. I supposed to have done that before the. So guys, I think I'll just solve one question. Let's see how it works. If I can go beyond one, then that's good because of our time. So my light shot is active now. So okay, so print screen now. So I need this information on my graph. So let me just copy it. Copy. Save. Oh, let me copy and save it in case. So that, because in case I want to post, I want to use it where I have my graph, but I will not run into trouble because I can't start solving this again. So let me just let me save it too. So copy and let me just save in case just save it. Okay, so let me save it here as solution or inequality solution or something like that. So let me keep that there. Okay, so I don't need this information again, guys. Hope you understand this first part. So if you need to if you don't understand, please just start the video again and take a look at. Okay, so guys, at this stage I need to clear my page. So let's go to the next question. Insert image. Okay, so the next question is the graph now. Because I told you earlier on that there are two stages. The first stage is to interpret the information given a series of simultaneous inequality, and we did that already. So the second stage, we are to investigate some characteristics, okay, of points. Now look at this question now. Can I bring this? Can I expand it? I think it's okay. Then let me see if I can post my. Let me go home. Let me see if I can post this now. Control V. Okay, it's not working. I trust you. Okay, so can I import that too and Let me see if I can import that too and place it side by side. Let me see if that is possible. Let me just import the solution and see if I can. I need this information. Okay, so can I carry it? Wow, thank God. Whoa, I've not tried this before now. Okay, so that's a good one. Okay, so I can work with it now. So now this question now says that can I bring this one here? Oh, wonderful. Can you help me? I don't need much drop. Uh hope that is the best. Control Z. I don't want it to alter my graph. Okay, so now the question here says that on the grid, this is part A. We are through with part A. So part B now. On the figure below, okay, or the Cartesian blue or grid, whatever. Draw a suitable diagram to illustrate the situation graphically, indicating the visible region. So guys, so let's get started with the first inequality. We want to plot this now. So I can go home now. So the first thing is to plot this inequality graph. I'm not going to take much time explaining this. Let me just explain first too. So the first thing is to just go for x equals to 3. So then before I now go ahead with this inequality. So x equals to 30 rather. X equals to 30. So I need a line now. Okay, now if you look at this, this is um greater or equals to. So when it is greater or equals to, you use solid line. But if it is strictly less than or strictly greater than, you use broken line. So I'm going to use solid line now. Most of the questions I have here, they are solid line. But perhaps if this were to be x strictly greater than or strictly less than, you are going to use this line here. But so I can't use this line. So you have to use this solid line. So guys, don't forget. So you use this solid line. Okay, so now go to 30 on x-axis. This is x-axis. So 30 is between 20 and 40. So you're going to draw a line across that. 30. I think I'm correct. Wow, graph. So that's that. So this is x equals to 30. This graph is x equals to 30. Now let me just label it so that we know what we are doing. So I can use any type of stuff to label. So this let me label it to this side. So this is okay. Or let me just point this. So look at this, the arrow. So that's for that. So that's it. That's for this graph. I don't know whether that's the best way to do that, but I think it's okay. My line seems not to even be. It's not aligned, but it's not bad. I don't know if I should do that again. Let me just do that again, please. 30. So this is 30 here. So you just need to be straight, and if not, then I will know what to do. So I think it's okay like this. So that's the first one. Let me just bring it down. Let me cut it through. Let me cut it through. So at least we know that it's between 20 and 30. So we remember that that's the graph. Okay, so next, this is greater or equals to. So the part greater than 30, this is part greater than 30, 40, 50, 60, 70. So that's the required region. So you are going to shade the unwanted region. So I can shade my unwanted region with broken line. I care little about that. So it's not going to affect it. So you can shade it with any. It's just shade that is, I cancel out this region. So the part I need is the part 30 and above. So to the right hand side of 30. So I don't want below 30. I don't want 20 down to 0. I don't want that. So this means you cancel. So cancel out the unwanted region. Okay, so leave the solution region unshaded. So that's what I did. So this is the graph of 30. So the next one is 60. Y equals to 60. So that in that case, I'll just draw one. I don't need to do this. Let me just explain. So take your line again. I need a solid line because it's greater or equals to. So go to 60. So this is 60 on y-axis. You draw a line across 60. And since it is greater than, I need part greater than 60. That is above the line. So I'm going to shade below the line. So that will give us the representation. I don't know if I should start. Maybe I need to tag my inequality. I may need to do that. Maybe let me just do that. Don't let me be lazy, guys. Let me just do that. I will tag all my inequalities now. Let me just start doing that. Okay, so let me just tag the first one. I can tag with laser. So this one is x. That's the inequality sign for that, 30. And this one is what am I writing, guys? That's why. So what happened? I'm correct, guys. x. It's called the x-axis. So I can be funny sometimes. Okay, 30. Okay, so this is y. Go to y 60. I was thinking some. It's not funny, guys. Okay, 60. So laser. So at least to indicate. So draw a line across 60. Okay, next, x plus y. So this one I'm going to use cover up method. Guys, I use cover up method. The implication is that when x equals to 0, y will be 200. So in that case, I'll go to y-axis. I need a solid now. Y-axis 200 on y-axis, and this is 200 on y-axis. So mean that when x equals to 0, I'm going to have 0, 200. So this point. Then if I cover up y, when y equals to 0, x also will be equal to 200. So go to 200 on x-axis. So this will be 200, 0. So now the inequality now. So join the two stuff now. So just join this 200 points with this 200 points here. So let me extend it beyond. So guys, and if you look at the inequality sign now, this is going to say less than. So it's the region less than 200, region less than 200, and to the left hand side too. So mean that I want the part under the below the graph. So I'm going to shade above the graph. So the solution region will be above the graph. So I can go ahead and do that. So I don't all this part, not from here. This is not out based on this. So it's just this graph that make this part to be out. So it's not based on this line, it's based on this line. So it's out now. So all this region, they are useless now because I cancel them out. All this region, they are out of the show, because the objective is to get the visible region. Okay, so this out of show now. So we have this part left. Let's just continue with the question. Now this question, this one is like I square out. This is the 8 here now. So I also use cover up method also here. That is when x equals to 0, and what is y, and when y equals to 0, what is x. So let me just so let's take y out. So when y equals to 0, so x will be 10x will be 900. So x will be 90. Do you see now? X will be 90. So go to 90 on x-axis. So this is 90 on x-axis. This is 100 here. This is 80 here. So 90 will be in between. Guys, hope I'm correct. This 90, right? How many square boxes do I have here, guys? Oh, because I cancel out, I can't see very well. 1, 2, 3. I think 90 should be here. Okay, that's 90 there. Okay, I'll be careful about that anyway. So similarly, when x equals to 0, so I will have 3y equals to 900. So y will be 900 divided by 3, and that will be 300. 300, right? So go to 300 on so when x equals to 0, so go to 300 on y-axis, because 90, that's 300. So 3 here, so 300, so 300 here, so this 300 here. That's perfect. I like that. So I will join these two guys now, this 90 and 300. So take your line again. This is 300 here, join with 90 here. So I just need to be careful. I will just tag this 90. I know that it's in between, so that when I want to work here, so I know that this point here is 90, 0, while this point here is 300, 0. So I know what I'm doing already. Then this point is 200. Okay, so so this is what I have in here. So this is less or equals to. So less or equals to will be below the line. I'm going to shade above the line, guys. Wow, this graph is everything is going out. So this above the graph is also out now, because this is less or equals to. So I need the portion less, the less than portion. So this part out now. Okay, guys, I just need to be fast now. So what else? So the final one, what happened there? Oh, 1, 2, 3, 4, 5. Okay, correct. So let me just tag this too, so that I don't lose track. Let me just tag let me tag that too. So this one is graph of 10, x plus 3y less or equals to 900, right? So that's the graph there. I wrote 100 instead of 900, so it's 900. Okay, so now we are here now. So I use cover up method. A lot of cover method. So cover up method here too. So let me just block let me just if you cover up y, let's just cover up x here. So when x equals to 0, what is y? So when x equals to 0, 3y equals to this, so y will be 100. So go to 100 on y-axis. This is 100 on y-axis. 100 on y-axis. Okay, so when y equals to 0, 2x will be 100. So that will be 150. So 150 on x-axis. So 150 will be here. This is 150 here. Between 140 and this. So I will join this now. So take a straight line, join 100 with 150 now. So a straight line. Linear programming is very interesting, guys. Okay, especially this question. So this is not funny, guys. This is a very wonderful question. I don't believe I'm going to have something like this. Okay, so this is greater than. So greater than means I don't want the part below the line. So the part below the line will be out of the game because I want the part above the line. So I'm going to cancel below the line. So I can go ahead and do that too. The only thing is that I must be careful what I'm doing because of my solution. So the part below the line is out of the show. Out, guys. So this region is out now. Okay, I think every other thing is okay. Then I need to tag this. Don't let me tag it down here because of this one, so I don't confuse it. So let me just write it on top of this place. So let me tag this one. So this one is graph of 2x plus 3y and greater or equals to 300. Okay, so finally 2y greater or equals to 3x, guys. So this is a wonderful one, guys, because if you look at question, the like from here it has been covered up method, but this is a new this is a very great this calls for a great concern, guys. You just have to learn this one. So I'm going to use transformation method to plot this graph, or better still, yes, let me just call like a gradient form. So I'm going to use before I can plot this graph, because I want to use gradient, I will use y as subject of formula so that I can have it as a form y equals to mx plus c. Then I can do rise and run. So now if 2y equals to, let me just use equals to explain. If I have 2y, because the inequality sign is just about shading below or above the line. So if I have 2y equals to 3x, so the intercept form, if I want to write this one in intercept form, so I'm going to have like y equals to 3 over 2x. That's all. Let's just say plus 0 because there's nothing else. 0 is additive identity. Okay, no, so it's now of the form y equals to mx plus c. So from here now, the m there is 3 over 2. That is the gradient. And you know that generally gradient is what? Gradient is change in y. That is y2 minus y1, like you guys know in coordinate geometry, divided by change in x. So the change in y can move up or down. So that's what we call rise. And x can go in a transformation. Do you remember? So delta x. So that change in x will be run. So because you can run to the left or to the right. So that's what we mean by right and run. So by implication, so this number up here is the y value. So and it's positive. So this means that you 3 step up, and this one is positive too. This one will now be 2 steps to the right hand side. Then from where the intercept c is 0 here. So the intercept is c. So we are starting from 0, from this point 0 here. So this is the reference point now. So from 0, 0, I'm going to take 2 steps. Don't forget that you can only move right or left before you can move up and down. So this by implication now. So 2 steps to the right, 3 step up. 2 steps to the right, 3 step up. So that's how I'm going to plot this graph now. So 3 steps to the right, 2 step up. So in that case, let me just go ahead with my line. Should I work with this? Yeah. um Guys, you have to be careful, so let's take a look at it. This is 20, 40, 60. The label is unique. It's 20, 20 unit, so I can take a square, so I can, it's okay with that. 20. Okay, so now, so let's plot the graph now. Um so this is 2 steps to the right, 3 steps up. So now 2 steps to the right, that will be 40. I'll be on 40. So 20 to 40, that is 2 steps to the right. Then 3 steps up, so that will be on 60. So this will be the first point. So from 0 to this point. In that case, let me just, can I change the color of this pen so that can I use lighter or something? Okay, so this is the first point here now. Let me just take something that we make it. Okay, let me use laser so it will be blinking. So the first one, so 2 steps to the right, then 3 steps up. 2 steps to the right, 3 steps up. Don't mind me, this 3 steps up against 40. So this place here. So this laser, so I'm using laser now so that we know what we are doing. So guys, something is there. Then from here now, continue the rule. 2 steps to the right and 3 steps up. So I'm on 40. So 2 steps we take 40 to 80. Yeah. Then 3 steps up from 60, and that will go to 120. So this will be the next one here. Then from here also, I'm on 80 now. 2 steps will take me to 120. Am I correct? Yes. Because 100 and 120. Then 3 steps up. So that will take me to 180. So this is it here. Then from 120, 2 steps to the right. That will take me to 160. 160. Okay. So I think that's it here. Then 3 steps up from 180. So that will take me to 240. Guys, this is not easy, guys. 160 to 240. Okay, so 240 is here. It's just that the best thing for me, I think I'll just try to use my, when I want to plot the graph, it will be very easy for me. Okay, then from 240 now, 2 steps to the right, I'm on 160. 160 will take me to 200 now. So that's the final, guys. I'm through. 200 here. So when I want to plot the graph, it will be very easy. Then I'm on 240. 240 3. That is that will take me to 300. Correct. So guys, I'm going to use my line now. That will be very easy. So now let me use my line to just join. So to use the line, it will be easy. So I'm starting from 0. 0. 2 steps to the right, then 3 steps up. 1, 2, 3. So I know where I am. Then 2 steps to the right, 3 steps up. So I'm here. 2 steps to the right, 3 steps up. I'm on 180. Guys. Okay, I'm on 180. From 180, I have to start all over. Can I start now? So I think I get it already. So from 180 to, it's just like to 300. So the idea is, this is from 0. So it's more like is a, hope this will be correct. Hope this line will be correct. Let me confirm. So 0, 20, 40, 40 end here, 40 to 80, 80 end here, good. 80 to 100, and 80 to 120, 120 end here. Then 120 to 160, 160 end here. Okay, 160 to 200, 200 end here. So 200 end against 300. So let me just use that one to confirm, because 200 end against 300. Let me use this one to confirm. So this is 300 here, and this is 200 here. So the first and the last will make sense. So it's correct. So the graph is correct. I just use this tool. So now, so what type of sign do we have there now? So I have this is greater or equals to. So greater or equals to means that I want above the graph. So I'm going to cancel below the graph. And this is the graph now. This seems to be the most difficult of the graph, guys. So this is 2y greater or equals to 3x. So since it is greater, so I'm going to shade below the graph. So I'm going to shade below the graph now. Guys, I think I'm going to make another tutorial for the second question, for more questions, because this question has taken the whole time already. So I'm going to make part 2 to solve more problems. And I think this is the most difficult problem you can ever come across. So I'll solve the subsequent question you're going to see in part 2 will be quite easy, and probably it's not going to involve a lot of stuff here. Okay guys, I'm through. So I have my solution region now. But that will be based on the question, but I can solve from here. Let me just give you points that the point we have here now. And I'm going to use the laser to do that. Or let me just use this. So what the examiner is going to ask us, I will go ahead for the question now. So I have this point here. I have this point. I didn't even shade. Did I shade any point here? Side? I have this point here. I have this point here. And I have this point here. So this is a quadrilateral. It's more like a kite. So let me just write R in the solution region. So the solution region, this is unshaded region, that is R. So this is the unshaded region. So let me go ahead and see the question that will come from here. I don't need to import that in the graph, so I'll just come here. So let's go ahead and see linear programming question. So let's see the final question from that. Question 1 final. So let's see the question here. So I'll just use slide shot to complete this. Okay, say that states which inequality does not affect the visible. States which inequality does not affect the visible region. Okay, so we have to state the inequality that does not affect the visible region out of all the inequalities we have. So how many of the inequality does not affect the visible region? So let's go back to our inequality and see which one not affect the inequality region. So I'm going to write the answer here. I will use light short, but not yet. So let's go back and see the inequality region that is out of the show, as in that is out of the show, right? So that is out of the show. Okay, so we have x30. If you look at this x30, this part is part of the visible region because is part of the visible region. If you look at x60, y60, this is y60 here. Y60 is completely out. Y60 is not part of the visible region because this is y60 here. It's not a part of the line that bounds the visible region. So the line that bounds, you see all the line that bound the visible region here. So y60 is out of the, so it's out of the line that bound because it's not bounded by the visible region. See, y60 here is not part of the line. The line, this line 1. So 2y 3x is part of the line that bound it. This one x30 bound 2x, this one. So the only one is y greater or equal to 60. So that's the solution to that one. I think let me just write it here now. So the only graph that did not affect the visible region is this guy here. So this guy here, let me use this. Let me put it in circle. So this guy is out. I don't know how to use circle, guys. Oh, I think I do. No, I don't even care about it, guys. let me go for rectangle. Don't waste my time. So this guy is out. So that's the solution to that question. So it's out of the game. So let's go back to the question again. What question do we have there? Then the hotel is awarded points on the number of sunbeds available for guests. Each wooden sunbed gain 4 points and each plastic sunbed gain 5 points. Okay, so this one I need to write the inequality solution for that. So 4.5 points. Okay, so by using an objective line or otherwise find the maximum number of points the hotel can be awarded and the number of each type of the sunbed that can correspond to the maximum. So now all I need to do now is sunbed, but now we need the maximum amount of points. So meaning that what I need here, let me just use slide shot before I go to the graph. What this question is trying to ask us to do now, because if I go back to the graph now, you see that we have different coordinates. I have 4 coordinates, so I can label it maybe A, B, C, and D. Guys, I think I'm going to import this question. Let me see what I can do with this question, guys. Let me just import it to the graph, guys. I think it's possible. LP final. Let me just import it to the graph. I can use it to cover up something because I don't want to keep track of this graph. Let's just go ahead and do that. We are rounding up already. I'll block this part, or maybe this part. I don't need some part there. I'll just, let me import the final, LP1 final. Yes, I think we can work with it. Okay, so let me just let me reduce it first. Can I reduce it? Oh, that's bad. Let me reduce it like something like this. Okay, I will also lose track. I think it's not too bad. I can read it like this. Okay, guys. Okay, I only need the solution region, so I only need this point, so I can bring it in here. So I think it's okay here. Can you stay, guy? I can also take it up. Okay, guys, I think everything is cool now. I can use my light shot now. So let me use light shot to finish up. Okay, let me use light shot to finish up now. Okay, so what? Yeah, I have it. So let me use this pen. Okay, now so we have solution to this one. The only part not bounded is the solution here is y greater or equals to 60. So that's the solution to this one. We have that already. So then so the hotel awarded point available story. Okay, so now each wooden point, now wooden, what is wooden? Wooden is x, if I'm not, yeah, wooden is x. So so wooden is x, don't forget that. And so and say that each wooden sum bed gain 4 points, so that will be like for something like 4x. So now what I'm writing now is what we call objective function, guys. What I'm writing is objective function. Don't forget that our objective function, we want to probably minimize our expenses. We don't want to spend much, or better still, we maximize our gain, our profits. So this is called objective function. So objective function, so that's what we are writing now. So objective function or equation, so it's an objective function. So now, so the objective function is what I'm writing now, D. So there the hotel is awarded points on the number of sun bed available for the guests. Each wooden sun bed 4 points, so that is 4x, and each plastic 5 points, so that is plus 5y. So I have this now. So this equation now. So I will now go for point x and y. Which one will give me the maximum? Because this one asks me that by using an objective line, otherwise find the maximum number of points. So my objective here is to find the maximum number of points, so that what value can x assume and what value can y assume, so that we have the greatest possible answer here. That is the question. So now let's go for the point I have here now. So I'm going to tag this point A. I have this point here now. So I don't need to write this point. Let's just quickly take this point here. If you look at this point now, if you trace it to the x-axis, this is 30. So I have 30, comma 30, comma 200. That's that point up here. So when x is 30, y is 200. That is this point here. Trace it down. This is 30. It's between 20 and 40. And if you trace this one to y-axis, that is 200. Then this point here is 30, 80. So I also have 30, 80. I have 30, 80. Okay. So I'm through with this point here. I'm through with this point here. This point here, I have 40. 40. Guys, can I see very well? I don't even need to waste much time. I have my solution already. That's 40, 70. Anyway, that's 40, 70. 40, 70. And finally, I have this point here. This point here is 60. 60, 100, I think. Yeah. 60, 100 or 60, 90, whatever. 60, 100. I'm very sure of that. Okay, so now out of these points now, which one will give us the maximum if you put in the solution? Definitely, since 5 y has coefficient 5, the coefficient of y is greater than x. So mean that the one with y large big y value will make sense. So we can consider something like this. This will make sense first, even though this is very small. Okay, so this is out of the show because it's bigger than that. Then if you compare this, definitely this is out of the show. Okay, we can compare these two. But if I do 40 times 60 and 500, so let's see, compare to 30 times 40. So let's see that now. So let's compare this last standing guys. So 200 times 5 will give me 1000. And then 4 times 4, so that's 1200. So I'm going to have 1200 if I were to use that. But if I were to use this one, I'm going to have 500 plus 240. So 240 plus those, definitely, so it's out of the show too. So the one that give us the maximum is this 30 200, this point here. So this point here give us the maximum, this point here. So this is the, so that's the point that give us the maximum. So guys, at this point, it need not to be 30 200, but if you look at it very well, if you plot your graph very well, it could be 30, but this is the point maybe. So and that's the maximum. So and the number of points we can have is 1200, guys. And that's the end of the tutorial on linear programming. So I'm going to make part 2 of this, but we're going to solve some simple questions. Okay, so guys, hope you enjoy the video. Please do well and subscribe to my channel. Do take good care of yourself, guys. Bye, guys. Bye, guys. Bye, guys. Okay, take care of yourself, guys. Cut here. So solve less of mathematics. Watch more